Okay, so we're going to do the last section of 1.1. I'm just going to make it a little bigger and then we'll start. Okay. So basically this particular section is going to help us draw the first quadrant, specify the coordinates of the first quadrant of the unit circle. And when we say unit circle, we'll introduce a lot more of it later, but for now I'm just giving you the basis of the foundation where we will draw the first quadrant of the unit circle. So unit circle is literally a circle, as the name suggests, whose radius is 1 unit. So, and is divided into multiple angles. And I'll talk about all of that. But now let's just focus on how to fill in the first quadrant of the unit circle. And when we get to the unit circle, we'll see how we will transfer it. So one step at a time. So again, I'm not going to go through the whole thing. I will go through the first triangle, and then I'll tell you how it actually gets transferred to the first quadrant. So if you look at the first triangle, this is a right angle triangle, and it's a special right triangle because it's 90 degrees, 30 degrees, so this will be 60 degrees. I have one measurement. The hypotenuse is always 1 in a unit circle because this is the hypotenuse, so it's always 1, so this is 1. If this is 1, I know I should be able to find the measurement of the other two sides because it's a 30, 60, 90. It has a ratio of 1 is to square root of 3 is to 2. So if my large side is 1, my small side, which is opposite 30 degrees, is going to be half. So this is 1, this is half. So what does that make my medium size? So let's just call it m. So I can set it up as a ratio. So square root of 3 over, sorry, there we go. Square root of 3 over m equals 2 over 1. So 2m equals square root of 3. So m equals square root of 3 over 2, and that's what this is going to be. So my three sides are half, small side, square root of 3 over 2, medium side, and the hypotenuse is 1. And there'll be similar work on the remaining triangles, and this actually gets transferred to the first quadrant because this is 30 degrees, so this is a 30, 60, 90 triangle. This is a 45, 45, 90, this is 30 degrees. This is a 45, 45, 90 triangle. This is 90, 90. And this is again 30, 60, 90 triangle, just set up in a different way. This is 60 degrees. And then you have the 90 degrees. And the coordinates that you will write for each one of them is basically coming from the sides. Okay, but instead of getting into all of that, what I'm going to do is I'm going to go to the next page. And this should help us. This table, if you can fill in this table, this will help us to fill in the first quadrant of the unit circle. And it's the first quadrant of the unit circle that's important because that gets copied to the remaining, as far as the coordinates are concerned. The angles will of course be different, but the coordinates get copied to the remaining three quadrants of the unit circle. So let's look at this table. So it has sine theta, cosine theta, tan theta, and then cosecant, secant, cotangent. We'll leave these three alone for now, and we will focus on 30, 45, 90. I also want to talk about 0 degree because my first quadrant starts at 0 degree and ends at 90 degrees. So I do want to go up to 90 degrees. Okay, so the easiest way to fill in, I can go back to my triangle, do all the work, and go from there, but that requires a little more work. So if there's one method that I'm going to teach you that hopefully will help you fill in the first quadrant. So what you do is, for sine theta from 0 degrees to 90 degrees, I want you to write the denominator. Everything is, it's a ratio. Remember, sine theta is a ratio, cosine theta is a ratio. In this ratio, you want the denominator to be 2. All the denominators. And then the numerator goes from, it's a square root, so square root of 0 to square root of 4. So square root of 0, square root of 1, square root of 2, and you'll see you will have to simplify it, square root of 3 and square root of 4. But we're not going to leave it like that. Square root of 0 is 0, 0, anything over 0. So sine of 0 degrees is 0. Square root of 1 is 1, so 1 over 2 is half. So sine 30 degree is half, which is basically coming from here. Sine of 30 degrees, sine is opposite over hypotenuse, half over 1 is half. So that's basically where it's coming from. And then square root of 2 over 2 stays as square root of 2 over 2. This cannot be simplified. Sine of 45 degrees, it comes from this triangle. If this is 1, these two will be square root of 2 over 2. And then sine of 60 degrees is square root of 3 over 2, is coming from this triangle, right? So this is 60 degrees, opposite sides, so square root of 3 over 2 over 1 is square root of 3 over 2. And square root of 4 over 2 is, square root of 4 is 2, 2 over 2 is 1. Okay, so let me repeat the method. For you to be able to fill in the sign in the first quadrant, sign of different degrees, 0, 30, 45, 60, 90 degrees, you start by having all the denominators as 2, and then the numerator square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, and then simplify what you can. Some of them cannot be simplified. Square root of 0 over 2 is 0, square root of 1 over 2 is half, and so on and so forth. So basically the sign values move from 0 to 1, the range, the output is from 0 to 1. Okay, now let's look at cosine theta. Cosine theta will follow the same rule except in the backward position. When I say backward, you start with square root of 4 over 2 here. So everything is still over 2. And then my numerator is going to be square root of 4 over 2, square root of 3, square root of 2. So you're going in the decreasing order. Square root of 1, square root of 0. And square root of 4 over 2 is 1. So you'll see that it is moving from 1 to 0. This moves from sine 0 is 0, sine 0 degrees 0. Cosine 0 degrees is 1. Square root of 3 over 2 stays as square root of 3 over 2. I'm just rewriting it. Square root of 2 over 2 stays as square root of 2 over 2. Square root of 1 over 2 is square root of 1 is 1. 1 over 2 is half. And square root of 0 over 2 is 0 over 2, which is 0. So these are the values. So if someone says what is sine of 30 degrees, it's half. What is sine of 45 degrees? Square root of 2 over 2. What is cosine of 60 degrees? It's half. So this is how you'll get the values. And the last thing we are going to do, for now I will not do cosecant, secant, cotangent because I want to focus, the first quadrant is, we're going to focus on filling in the values for sine, cosine and tan. So tangent is, I'm not sure if we have talked about this or maybe we have and I'm not sure, but basically tan theta can be represented as a ratio of sine theta over cosine theta. So that's all I'm going to do. I have the sine theta and cosine theta in front of me. I just have to divide them. So tan theta equals sine theta over cosine theta. So 0 over 1 equals 0. Half over square root of 3 over 2 is how much? Half over square root of 3 over 2 is actually, what will happen is the 2 and the 2 will get cancelled when you flip it. What you will be left with 1 over square root of 3, but you can't leave, so you rationalize the denominator because you have an irrational number, and the final value is 1 times square root of 3 is square root of 3 over 3. So tan of 30 degree is square root of 3. I hope the work is clear. Okay. And then tan of 45 is sine over cosine, so square root of 2 over 2 over square root of 2 over 2 will be 1. And this one is again sine, so square root of 3 over 2 over half is just square root of 3. And what do you think is going to be 1 over 0? Remember, when you have 0 in the denominator, it is undefined. So you leave it as undefined. Okay, and these ratios are true for all the special right triangles. Okay, please memorize these values. So more than memorizing, hopefully you saw a pattern and hopefully that should help us fill in the first quadrant. And we will stop right here.